These are video notes on subtracting rational numbers. Before we begin, let's do a quick review of what a rational number is. A rational number is any number that can be written as a fraction, and that will include integers, all fractions, and any decimal that is either repeating or terminating. So all of those count as rational numbers, and that's what we're going to look at how to subtract today. To begin, let's review our rules for all of our subtraction problems. These are going to be the same as they were for when we subtracted integers. So first, if we have a subtraction problem, we're going to rewrite it. So rewrite every subtraction problem as an addition problem. And we're going to do that using keep, add, opposite. Once we've rewritten it as an addition problem, then we can use our adding rules. So if we're adding two numbers with the same signs, then we're going to add the absolute values and we're going to keep the same sign. So that means a positive plus a positive is positive, and a negative plus a negative is negative, not to be confused with your multiplication rules. And then if we have two rational numbers with different signs, then instead of adding, we're going to subtract the absolute values, and then we're going to use the sign of the number with the larger absolute value. And again, that's what we used for integers. We're going to be able to do the same exact thing for rational numbers. To start, we're going to subtract 12 and 8/10 minus 21 and 6/10. This is a subtraction problem, so I'm going to rewrite it as addition. So we're going to use keep, add, opposite. 12 and 8/10 stays exactly the same. Subtraction changes to addition, and the opposite of 21 and 6/10 is negative 21 and 6/10. Now these have different signs, so I am going to subtract the absolute values. I'm going to put the number with the greater absolute value on top, so 21 is bigger than 12. And then I have enough where I can borrow if I set it up that way. So we can borrow, and when I subtract, I get 8 and 8/10. I started off with 12 positives and 21 negatives, so my final answer is going to be negative. Since 21 and 6/10 has the greater absolute value, I need to keep that sign. Okay, so my final answer is negative 8 and 8/10. Next, we're going to do an example with some mixed numbers. I'm going to begin by changing this into an addition problem. And again, this is only for subtraction that we're using keep, add, opposite. Negative 4 and 1/6 plus positive 1 and 1/2. My next step is to convert mixed numbers into improper fractions. Now to change my mixed numbers into improper fractions, I'm going to multiply 4 times 6, which is 24, and then I'm going to add the numerator. So 24 plus 1 is 25. The denominator stays the same, and the negative symbol stays in front. We're still adding, and then I'm going to convert 1 and 1/2. So 2 times 1 is 2, plus 1 is 3. So I have negative 25/6 plus 3/2. And my next step is to find common denominator. So I'm going to look for a number that 6 and 2 both have as a multiple, or a number that they can both multiply into. And for this case, the easiest number would be to use 6, since 6 goes into 6, and 2 also can multiply into 6. Now my first fraction is already out of 6, so I'm just going to copy that, negative 25/6. My second fraction, I had to multiply 2 times 3 in order to get to 6. So if that's what I did for the denominator, I'm going to do the same exact thing for the numerator, which is going to give me a numerator of 9. So 3 halves equals 9 over 6. It's just a different way to write it. Basically, if it wasn't simplified, it could be written as 9/6. Okay, next, I'm ready to add the numerators. So if I add negative 25 plus 9, I can subtract the absolute values since they have different signs. When I do that, I get 16. I had more negative than positive, so that's going to be negative 16. And then the denominator just stays the same. Okay, now we can simplify. Both of these are even. So if I divide both the numerator and the denominator by 2, I get negative 8/3. So now it's in simplified form. I'm just going to change this back into a mixed number. And the way that I can do that is figure out how many times 3 goes into 8 and then write the leftover as a fraction. If I want, I can even set this up as a division problem and do 8 divided by 3. Remember, numerator inside the box, denominator outside. So now 3 goes into 8 2 times. 2 times 3 is 6. And then we're going to subtract. And then instead of turning it into a decimal, I'm going to rewrite this as 2 over 3. So I get an answer of 2 2/3. This was a negative number, so I'm going to keep the negative, and my final answer is negative 2 2/3. Okay, next, I want you to try all 6 of the problems on your sheet. Pause the video, and then once you have some answers, go ahead and hit play to check them. All right, now that you've had a chance to try these, we're going to rewrite number 1 as an addition problem. So we're going to do 1/3 plus positive 1/3. These already have common denominators, and 1 plus 1 is 2. So our final answer is 2/3. Okay, next on number 2, same thing. We're going to do keep, add, opposite. So this time we are adding 2 negative numbers together. Just like we already saw, we're going to change negative 3 1/3 into improper. So 3 times 3 is 9, plus 1 is 10. So that's going to become negative 10/3 plus negative 5/6. And then we're going to change both of these so that they have a denominator of 6. Second fraction stays the same. And on the first one, I need to multiply by 2. So negative 10 times 2 is negative 20. And then I can add negative 20 plus 5 is negative 15. And then I can both simplify and change this into a mixed number. These can both be divided by 3. So we'll get negative 5 halves. And then I can change negative 5 halves by dividing. 2 goes into 5 twice, with 1 left over. So that tells me that negative 5 halves is equal to negative 2 1/2. Okay, third example, we have 4 1/2 minus 5 1/4. So we're going to change this. Keep, add, opposite. Okay, changing these into improper fractions. The first one's going to be 9 halves, and the second one is going to be 21/4, or negative 21/4. The common denominator I can use is 4. The second fraction is going to stay the same, and the first one I multiplied by 2, and 9 times 2 is 18. So now I'm going to add 18 plus negative 21, which is negative 3, and the denominator stays the same. So we get negative 3/4 for number 3. Okay, next, number 4, we're going to rewrite it, keep, add, opposite. These have the same signs, so I'm going to add the absolute values, line up your decimal point, and we're going to use the same sign as what those both started with. So a negative plus a negative is more negative. So we get negative 15 and 1/10. Number 5, again, keep, add, opposite. So we've got keep, add, opposite. And these have different signs, so we're going to subtract the absolute values, or we can recognize that those are opposites, and opposites always add up to 0. And finally, number 6, I'm going to have 40/100ths plus positive 7/100ths. And we can now just line up our decimal points and add. So final answer is 48/100ths, and that's positive. All right, thank you for watching. Hopefully that helps out with subtracting rationals. Be sure you hang on to these notes because they will be really helpful.